All right, class. So today we're in week one of fourth quarter. We're in week one of fourth quarter. And on Friday, we started our first page of notes because that's technically when the quarter actually started. And we talked about the real number system. The real number system is used to categorize numbers, to put numbers in categories by their characteristics. Okay, so here we chose to display that by using what you would call a chart or a graphic organizer. And at the top of the chart, we have real numbers. Any and every number is a real number. So every number you can think of is going to be a real number. Real numbers are broken into two different categories. You have rational numbers and irrational numbers. Rational numbers are numbers that can be written as a fraction. Irrational numbers are numbers that cannot be written as a fraction, cannot be written as a fraction, okay? There are three different types of irrational numbers. You have pi, which is the decimal for pi is a non-terminating decimal. It continues without n. It doesn't have a pattern to it. There's no pattern as to how that number continues. So you have 3.14, so on and so forth, and it never ever ends. That's what makes the number for pi irrational. You cannot write it as a fraction. It's not as easy as putting pi over 1. Okay, you can't do that. All right, so the other type of irrational number is non-perfect roots. Your non-perfect roots are the roots when you type them in the calculator, you get a decimal as an answer. Okay, so those are your non-perfect roots. They are irrational. You cannot write those as fractions either. Non-terminating decimals are decimals that continue on and on. They do not have an end to it, and there's no pattern as to how they are continuing. Okay, unlike repeated decimals, you know what number is coming next in a repeated decimal, but in a non-terminating decimal, the decimals that have the dot 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 at the end, you don't know what number is coming next. Therefore, it is an irrational number. You can't write it as a fraction because you don't know how it ends, and it never ends. So you cannot write it as a fraction. Your rational numbers are broken into two groups. You got non-integers, that's where your fractions and decimals go, and you have integers. Integers do not have fractions attached to them, do not have decimals attached to them. So by definition, an integer is a whole number and they're opposites. So it's positive numbers, negative numbers, and zero. They do not have fractions or decimals attached. Integers are broken into two groups. So an integer is either a negative number or a whole number. Negative numbers are numbers that are less than zero. Again, they do not have fractions attached to them. They do not have decimals attached to them. Whole numbers start with 0, 1, 2, 3, 4, all the way to the positive infinity. That means it goes on forever. They do not have fractions attached to them. They do not have decimals attached to them. They do not have negatives attached to them either. Okay? The last group that we're going to talk about here is going to be whole numbers are broken into either it's a 0. 0 is all by itself because 0 is one of them special numbers. It's neither positive nor negative. It's neutral. It can be a placeholder. And by definition, 0 has no value. 0 has no value. The last category are natural numbers. These are the numbers that you learn first. These are your counting numbers. When you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you count. And it goes on to the positive infinity. Again, natural numbers do not have decimals attached to them, do not have negatives attached to them, do not have decimals attached to them. Okay? All right. Here, we're going to add a little bit more to this page, and then we're going to be finished with the first page of notes, okay? So far, these are the numbers that we did on Friday, and we know that any and every number is a real number, so that's why we have checks in all these boxes, because all of these numbers are real numbers. Any and every number is a real number. Now, a number, notice, can either be rational or irrational, but that's it. So all real numbers are either one or the other, but they can't be both. Okay? Pi is an irrational number because remember, it is a decimal that continues on and on and on, and you cannot write it as a fraction. 7 is a rational number because you can write that as a fraction, 7/1. 1/2 is a fraction, so it's rational. -2, you can write as a fraction by putting a 1 under it. 6, you can write as a fraction. You can put a 1 under it. This repeated decimal, you know that 3 is going to come next. So you can write it as a fraction, 3/9, and reduce it. This next number, you can write this as a fraction, okay? It'd be a big fraction, but you can still write this as a fraction because it stops, okay? It stops. It's a terminating decimal. You can write it as a fraction. This next number, you cannot write it as a fraction because you don't know what number is coming next. How do I know that? Because I have these dots on the end, like to be continued. The square root of 36 is equal to 6. Since it's equal to a whole number, it is rational. If it was equal to a decimal, it would be irrational because it would be a non-perfect root, such as the square root of 12. It is a decimal. When you type this in your calculator, you get a decimal. So it is irrational. Okay? Any questions about the difference between rational, numbers that can be written as a fraction, and irrational, numbers that cannot be written as a fraction?
And guys, remember, if you're ever confused about the square roots, a square root of a number is a number multiplied by itself. So if you're not sure if there's a number that multiplies by itself, you can type in 1, 2 in your calculator and hit the square root sign, and it will show you exactly what the decimal is.
Any questions about that? And I will show you here in a minute. I got to pull my calculator out my bag, but I'll show you that in a minute as well. Okay? All right, so we're gonna add another category. We'll add here, another column. We're gonna add integers. We're gonna add whole numbers. We're gonna abbreviate numbers by putting a number sign. Whole numbers, and the last one we got natural numbers. We're gonna add these to the list. Okay? Add that to the table is what I meant to say. So we have integers, whole numbers, and natural numbers. And I'm going to put the symbol for natural number. So now we got to decide does these numbers fall into this category. First and foremost, if it's irrational, it cannot fall in any other category. It's just real and irrational. So that's it. Can't be an integer, it can't be a whole number, it can't be a natural number. Okay? So let's look at number 7. Number 7 is a whole number. So it is also an integer, okay, because all whole numbers are also integers. It is also a whole number, and it's a natural number because it's a counting number. 1, 2, 3, 4, 5, 6, 7. So 7 is all of these. Any questions about how I know 7 is an integer? 7 is a whole number, and 7 is also a natural or counting number.
And you can go back to your flow chart from our notes on Friday for notes if you need to try to figure that out.
Yep, and this is the flow chart.
All that information is there
here that you can use to figure that out. Okay, so let's look at 1/2. Okay, let's look at 1/2. 1/2 is not an integer or a whole number or a counting number. Okay, it is only rational because it is only rational because it's a fraction. You cannot have a fraction as an integer or as a whole number or as a counting number. So all it is real and rational. That's all it can be. -2 is an integer. Okay, it's a negative number. It's an integer. Doesn't have a fraction or a decimal attached to it. So it is an integer. But it is not a whole number. Whole numbers start at 0, 1, 2, 3, 4, 5. And it is not a natural number either. It is not a counting number. 6. Well, 6 is an integer. It's a positive number. It does not have a fraction attached to it. It does not have a decimal attached to it. Okay? So it is an integer. It is also a whole number. Okay? 0, 1, 2, 3, 4, 5, 6. It's a whole number. It is also a counting number. When you count 1, 2, 3, 4, 5, 6, it is a counting number as well. So 6 is all of these. It falls into all of these categories. This decimal, because it's a decimal, it's not an integer, it's not a whole number, and it's not a counting number. It is rational and real. That's all it can be. All right, rational and real. Okay. Decimal, same thing. It is not an integer, it's not a whole number, it's not a natural number. Remember, none of these categories have decimals or fractions in them. Okay, this is irrational. Remember, if it's real and irrational, that's all it can be, is real and irrational. Cannot be anything else. The square root of 6. Well, 36. The square root of 36 is 6. So since 6 is an integer, let me mark it as an integer. 6 is also a whole number, so we mark it as a whole number. 6 is also a counting number, so we mark it as a natural number. Okay? The square root of 12, remember, is irrational. So if a number is irrational, it can't be anything else but real and irrational, and that's it. Any questions about this table? I'll pause for the calls just in case, okay? Give you a chance to catch up. Okay, so now we're going to do the guided practice problems. I already told you where to find the guided practice problems on the Canvas page, on our weekly page at the top. Some of you have printed it out and you're going to write on it, and others of you are going to use the writing tool on Cami to answer the questions. Either way, it's fine as long as you show your work. Okay? Raise your hand if you need more time to get to this. Okay, I'm going to keep going. All right, so this is what we are doing here on this particular page. All right, this is another diagram that you'll see a lot of times, and I'm going to explain the diagram to you, and then we're going to put the numbers in the diagram. Let me zoom in just a little bit closer because some of you, it was a little hard to see just a minute ago. Okay. All right, that's a little better. All right, so here it says, write each number in the correct location in the Venn diagram, okay? Which that's the name of this type of graph that you see. Each number should be written only once, okay? All right, so we're going to probably write the numbers more than once in the beginning, and then where we see it in multiple places, we can probably just erase it because I don't want you to get confused with this assignment. All right, so let's look at this. It says these are our real numbers. Remember, I told you any and every number is a real number. So all of these categories are real numbers. Rational numbers are real numbers. Integers are real numbers. Whole numbers are real numbers. Even irrational numbers are real numbers. That's why it's in this circle of real numbers, because every number you can think of is going to be a real number. Okay? Rational numbers are numbers that can be written as a fraction. Every integer is a rational number. Every whole number is a rational number. That's why they have the integer circle inside of the rational circle. They have the whole number circle inside of the rational circle, because integers and whole numbers are also rational numbers. Okay? Look at integers. Integers, integers are, most of all whole numbers, all whole numbers, actually, all whole numbers are also integers. That's why you see this whole number circle right here inside of the integer circle, because all whole numbers are going to be integers. Okay? Any questions about these circles on this side? Notice how integer is a circle by itself. Because if it's a real number and it's an integer, all it can be is a real number and integer. That's it. It cannot be anything else. And notice how these two circles don't overlap. Rational and irrational. They don't overlap because either a number is going to be rational or it's going to be irrational, but it cannot be both. It can't be both. So that's why you don't see these two circles, these two big circles right here overlapping, because either a number is rational or it's irrational, but it's not both. All right, so let's go one by one. Let's put 6 in its right box. Okay, -6 is a real number, but what does it fall in? Rational or irrational? It falls in under rational because you can write it as a fraction. But not only is it rational, but it's also an integer. Well, is it a whole number? No. So we're just going to put -6 under integers because look, this integer box is still, circle is still included as a rational number, and it's still inside the big circle of a real number as well. So we're going to put -6 here, and let's mark -6 out because we've already put it in the appropriate circle. Any questions about that?
If anyone's confused by that, you can go ahead and write it in the real numbers and the rational numbers too. Just realize it's going to get a little crowded. So if that confuses you about the graphic we have here, you can write it in all 3 places.
All right. Let's look at this decimal. 2.73. 2.73, it's a terminating decimal. It stops. It doesn't have the dots at the end. It's not even a repeated decimal. It's a terminating decimal. So, of course, it's a real number because every number is a real number. It is rational. Okay, it is a rational number. Is it an integer? No, because we don't have fractions or decimals as integers. Okay, so we're going to put it in the rational circle. Okay, it's real and rational, and that's all it can be. Is real and rational. Integers do not have fractions or decimals attached to it. Whole numbers do not have fractions or decimals attached to it. Any questions so far? Okay. The fraction 3/7. 3/7, like every number, is a real number. Is it rational or is it irrational? Can somebody tell me if it's rational or irrational? Anybody? According. All right. Okay, Miss Reyes, which one is it? 3/7 is a fraction. Okay, guys. So remember, by definition, rational numbers are numbers that can be written as a fraction. So this is where I'm going to put 3/7. I'm going to put it here because it is a fraction. Okay, it can't be an integer because remember, integers are not fractions. Whole numbers are not fractions either. I'm gonna mark that out. The square root of 2. When I type in, and I should have already had my calculator ready. While I was talking to myself earlier, I should have just got my calculator out, right? Put my calculator back in. I think I put it back in. Yeah, I did. I put it in my car. I didn't take it home. All right, so when you type in a square root, this is how you type it in, okay? You press the second button here, and you go down and press the x squared. So when I type in the square root of 2, okay, I type in square root of 2, you see how I get a decimal? So this is irrational. It's irrational because I got a decimal as an answer. So I'm going to put it under irrational. Remember, if it's irrational, that's all it can be, is real and irrational, because every number is a real number. All right, so now we got the square root of 9. If I type in the square root of 9, some of us know that by heart. What one number can be multiplied times itself to give you 9? Oops, sorry, y'all. 3. Very good. The whole number 3. So since it's a whole number, 3 is my answer. Good job, babe. That's going to be a rational number. 3, is 3 an integer? Anybody? Is 3 an integer? Yes, it is. Thank you. So since 3 is an integer, it can go here. Is 3 also a whole number? Yes, it is. So I'm going to put the square root of 9 here because it's in all of this whole number circle is in all of these circles. So I don't have to keep writing it over and over again. Okay. If it's a whole number, it's understood to be in the circle for integers. It's also understood to be in the circle for rational numbers, and it's all of it is inside the circle for real numbers. Okay. Let's look at negative 100. Okay. Negative 100. Anybody? Is negative 100 rational or is it irrational? Anybody know? It's very rational. Good job. Okay. Thank you, babe. So since it is rational, now we're looking to see if it's an integer. Is negative 100 an integer? Somebody said no, and that's a good guess, but it is an integer. It's a high number, but it is still an integer, okay? It doesn't have a decimal attached to it, and it does not have a fraction attached to it, so it is an integer. But it is not a whole number, okay? Because whole numbers are not negatives, they don't have decimals attached to it, and they don't have fractions. So we're going to put negative 100 here. All right? Let's look at 0. All right? 0. Is 0, well, we know it's a real number because every number is a real number. Is it rational or irrational? Anybody know? It's very rational. You can write it as a fraction. Good job. Is it an integer? Is it an integer? Any guesses? It's okay to be wrong, you know? Yeah, it is an integer. Is it a whole number? It is a whole number, okay? So it goes here. It is a whole number. Whole numbers start at 0, so it definitely includes 0, okay? Pi. Is pi rational or is it irrational? It's very irrational. Very good. And if it's irrational, that's all it can be is real and irrational. Good job. Now we got 1. Is 1 rational or irrational? Very rational. Good job. You can write 1 as a fraction. Good. Is 1 an integer? Yes, it is. Is 1 a whole number? Yes, it is. So we're going to put it here. Remember that this circle is also an integer. It's also a rational number, and it's also a real number, okay? All right. Let's look at negative 1/2. Is negative 1/2 rational or irrational? It's rational because it's a fraction. All fractions, any number that can be written as a fraction is a rational number. So it is definitely rational. But is it an integer? No, it's not. It's a negative fraction, but it's not an integer because integers cannot have fractions or decimals attached. So negative 1/2 is just going to go right here under rational. Okay. All right. Let's look at this negative decimal. Okay. Jonathan, sit up, baby. This negative decimal, we got negative 3.8. Okay. Is that rational or is that irrational? Which one is that, y'all? Is it rational? Okay, it is rational, all right, because it stops. It's a decimal that stops. It doesn't have the dots at the end. So it's rational. And since it's a decimal, it can't be an integer or a whole number. So we just put it in this little circle right here. Okay, mark this out. Now I have this repeated decimal. Are repeated decimals rational or irrational? Anybody know? Any guesses? Yes, baby, what is it? Irrational. Almost. It's rational because I do know what number is coming next, and that's a great guess. Thank you for giving your answer. It is going to be rational because I know what number is coming next. 42, 42, 42. So I can write that as a fraction since I know what number is coming next. Okay. Great job. It's not an integer or whole number because decimals or fractions cannot be integers or whole numbers. Okay. Let's look at this last number. This is a long number and it has these little dots at the end. Is it rational or irrational? Very good, babe. It is irrational. Okay, I don't know what number is coming next, so I cannot write it as a fraction. Excellent job there. Okay, excellent job. Any questions about that? All right. All right, so let's look at the bottom where we're going to say true or false, and then we're going to explain. Let's see. All whole numbers are integers. every whole number is an integer. Is that true or false? Anybody? Yes. Oh, you needed a screenshot of this? Yeah. Okay, that's fine. Let me know when you have your screenshot, okay? You got it? Good deal. Okay, you're welcome. All whole numbers are integers. Look at where whole numbers are. Every single whole number is in the circle for an integer. So this is going to be true. You said zoom in a little bit?
They couldn't see what you were pointing at because it wasn't on the screen.
Oh, gotcha. Sorry, y'all. I'll do it again, babe. You see whole numbers? Whole numbers are within the circle for integers because every single whole number, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, is also going to be an integer. Okay, so this is going to be true. This is going to be true, and we're going to abbreviate because all whole numbers are integers.
That was a good job, Jonathan.
Okay, and I'll pause, give you a chance to write, okay? So number 2, it says all integers are whole numbers. Okay, so are all integers going to be whole numbers though? No, this is false. This is false. All integers are not whole numbers because whole numbers do not include negative numbers. Because whole numbers do not include negative numbers. Integers do, but whole numbers do not. Whole numbers do not include the negative numbers. Okay? And I'll pause, give you a chance to write. Number 3, some rational numbers are integers. Okay? So some rational numbers are integers. Doesn't say all of them. It just says some rational numbers are integers. And that is true. Some of them are integers, y'all. That's true. Some of them are integers. Remember, integers are whole numbers and their opposites. True, because integers can be written as a fraction. Okay? The last one, it says some whole numbers are irrational. Is that true or false that some of these whole numbers are irrational? Is that true? No, none of them are. You see how whole numbers is over here as a rational number? And remember I told you that a number can't be both rational and irrational. It's either one or the other. Okay? So this is false because whole numbers are rational numbers. And a number, guys, a number cannot be both rational and irrational. It's either one or the other. Okay? All right, and this is all that we're going to have time to do today. Tomorrow, I'll just pick up where I left off, and wherever I finish tomorrow is whatever we're going to submit. Okay? Any questions?
I'm going to come around, and whoever has a complete note sheet to show me, I'm going to give them a piece of candy.
Okay. If you're allergic to peanuts, please don't take a piece of candy because all this candy has peanuts in it, okay? All right, I'm going to stop the video at this time. Please make sure that you rewatch if you need to, okay? All right. Have a great day.